Okay, so what we're looking at here is we're looking at one of the formulas that's been kind of half filled in. And we're needing to kind of work backwards to figure out what the full angle was and what the original trig function was. So we're going to look at those formulas where we were talking about our addition and subtraction and see which one has the cosines together and the sines together and a plus. So looking at those formulas that we wrote down yesterday, our addition and subtraction formulas. I think I might have written down the day before too. Oop. Is that a real sneeze?
Yes, sorry.
Bless you. It sounded like a stage sneeze, like you're pretending. All right, so when it has the cosines together and the sines together, that's going to be cosine as the trig function. So if you look at those formulas, cosine links to keep the cosines together. Sine makes friends with everybody, so it's sine has sine, cosine, sine, cosine. But cosine also likes to change it up on its sines. So when the cosine formula has a plus over here, it means it's a minus inside. So this is the expanded out version of the cosine of 78 minus 18. If I was to expand this out, we would wind up with exactly that. So it's going backwards through that formula, which is not a common way we do it, but it's kind of one of those making this go deeper in your brain kind of deals. So let's simplify this a little bit and see if we can find an exact value. Because what is 78 minus 18?
No.
Try that again.
60.
60.
Uh-huh.
Dude, chill. What's cosine of 60? Wow. So this whole gigantic gargantuan formula of craziness equals 1/2. I love those, right? Alright. So when they give you, because there's problems like this on the homework, they give you one of these big formulas, they're asking you to go match them up with our addition and subtraction formulas and see which one doesn't match to. And we're going to go backwards. Let's not play with the scissors like that. Don't even pretend like I can't see them in your left hand. Not going to pretend we don't have the scissors. We're going to pretend we don't have a left hand. That was a choice. Yes, dear. Because the formula for our addition, for the this difference of cosines, if we were to do, like, I'm going to write it down up here. So, zoom out. The formula for the cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. So it matches up the fact that this matches here and this matches here with a plus if it's the difference between the two angles. So it's using the formula just backwards. So the sines aren't actually a part of it. This whole thing means this. Okay, we're going to do another one like this, just to kind of practice it because it's a little weird. So we have sine of 140 cosine 50, cosine 140 sine 50. And we're going to look at those formulas and see which trig function this matches for. Which one gives us each a sine and a cosine and uses a plus. because this is sine of alpha cosine beta, cosine alpha sine beta. So if you look back at our formulas, sine likes to mix it up. Sine takes one of each. So it's going to use sine. And we just have to figure out what the relationship between the 140 and the 50 is. Are we going to put a plus or a minus in here? A plus. This matches up with the sine formula. They just flip-flopped these because they're jerks. But it means the same things. This is the product, and it doesn't matter what order we multiply things in. So they're really asking for here, what is the sine of, when we simplify this? 190 degrees. Do we know the sine of 190? Off the top of my head. Could we break it up into pieces and do it? What pieces would we break it into? We can't do 180 and 10 because I don't know 10. 135 and 45? Yeah, that looks like I would do it. Oh, that's 180. Yeah, that's 180. Yep, so that's not quite there. It's closer. Do we have any sums that we know that could do this? I didn't see one. We cannot get an exact answer. This is as close as we can get. That's why the instructions are going to say evaluate if possible. This one we can't find a more exact answer. We cannot get more exact than that. So it's a good idea to stop and look, but we're not always going to be able to find an exact answer at this point. Okay, we're going to do one more like this. Because we've done a couple in degrees, I want to do a radian. So dramatic. All right, so we're expressing this as one trigonometric function of one angle. So we're going to figure out which formula this matches, and then we're going to evaluate if we can. So which trig function are we going to have here? Which one keeps our cosines together and our sines together? I heard someone say it. It was very quiet, though. Cosine. Cosine likes to keep its cosines together. So the formula for cosine keeps our cosines together. We just need to figure out what our relationship is between the two angles. Are we going to add the two angles or subtract the two angles? Add the two angles. I got no issues with grapes as long as you don't drop it here on the floor. Go for it. All right, let's simplify this. I need this to be one angle. So what is pi over 7 plus pi over 5? So I'm going to take a little side step over here. We're going to get those to a common denominator of what? What's their common denominator? 35. So we're going to wind up with 5 pi plus 7 pi over 35. So what's our angle? We have 12 pi over 35. Can we evaluate that? Can I get like an answer? Even if we break it apart, these would be the only real pieces we could break it apart into. 35 is not going to get down into an over 6 or an over 3 or an over 4. Those are the only ones we know off the top of our head. 35 doesn't have those as factors, so we're not going to be able to break this down into further pieces. So this is where we're going to stop. This is our single trigonometric function, which I struggle over that word every time I have to translate it. Our single trigonometric function of one angle. But we cannot evaluate it because we don't have over 35 in our library of knowledge base. Okay. In the homework, we're given things like this where it asks us to verify. Like this. So we have to verify that the sine of some angle plus 3 pi is the opposite of sine of that angle. So we pick one side to work with, and I'm going to say I can do things with this side where this side's way more simplified. So I'm going to take this left-hand side, and we're going to apply the sum of sine formula to this, because we're adding these two pieces. So when we look at our addition of angles in sine, that's when we take our sine of the first angle, so sine of x, times cosine of the second, cosine of 3 pi, and we're going to add it to sine of the second angle, 3 pi, times cosine of the first arm, cosine x. So the first thing we do is we write out that formula and put in the values that we have. Then we're going to try and simplify these things. 3 pi, that's coterminal with what? Pi. So this is the same thing as saying, I'm going to change colors, sine of x cosine pi plus sine of pi cosine of x. Because 3 pi and pi are coterminal. So what is the cosine of pi? -1. What is sine of pi? 0. So if we have 0 times cosine of x and -1 times sine of x, starting to see what's going to happen here? 0 times cosine of x means that whole piece just 0. Nothing. So we don't even need to write it. So we wind up with -1 times the sine of x, also known as minus sine of x, or the opposite of the sine of x. And that's exactly what we were going for over here. So that's what they mean when they say verify. It's going to be, so in this chapter, all the verifying stuff is going to use one of these sum or addition or subtraction formulas. Okay, so I wanted to walk through one of those because you look at that and you go, ew, where do we even start? It's going to have a sum or a difference formula in it. You're going to write it out and simplify. Because I'm going to spend the rest of the time on the weirdest looking problems on the homework. Because we're going to give problems that look like that. I know, we got to look at this and we go, what the? plot that. So it says use the given conditions to find the exact value of the expression. And they give them to you, and they usually like almost smash them together like this, which is obnoxious because these are our given conditions, and this is the expression we are asked to evaluate. So we're going to take the information that I underlined in green and use it to evaluate purple. Bless you. So we're told that sine of alpha is negative 5 over 13, and that the tangent of alpha is positive. Tangent of alpha is greater than 0. So if sine is negative and tangent is positive, what quadrant is it in? Means this whole thing's going to be in quadrant 3. So we're going to start by making a sketch so that we can figure out where the heck this sucker is. Ooh. So I'm going to give myself a little coordinate grid over here. And we know this alpha is somewhere in quadrant 3. It doesn't really matter where in quadrant 3. We just know it's somewhere over here. So this is my alpha. It's the acute angle with my x-axis. So if that's my alpha, and we know that sine of alpha is negative 5 over 13, I know that this sine, SOHCAHTOA, opposite over hypotenuse, right? So the opposite of my angle is going to be negative 5. My hypotenuse is 13. How can I figure out the adjacent side? This side here. I'm going to fix that negative 5. I don't like it. That's worse. How can I figure out that missing side? Oh, that's much better. Maybe we call it B. Say it again. Pythagorean theorem. I know negative 5 squared plus B squared has to equal 13 squared. So I know 25 plus B squared equals 169. Or that B squared is 144. So what's B? 12. Is it going to be a positive 12 or a negative 12? Negative, because we're in quadrant 3, so my sine is negative and my cosine is negative. So having this little sketch is going to make evaluating this way, way easier, because this whole thing describes my alpha. That is the worst alpha I have ever drawn. Holy cow. There we go. It looked like a fish. So when we're looking to evaluate sine of alpha minus pi over 3, I'm going to start by writing out that formula. So I'm going to take my difference of angles of sine. Well, we write out that formula. So we're going to have the sine of alpha times cosine of pi over 3. And since it's sine, it uses the same sign, so we're going to subtract sine of pi over 3 cosine alpha. I'm just going to give us a little barrier over here so they don't smush together. And then we're going to come evaluate each of these pieces. We want to find sine of alpha. So over here, we have a lot of information about alpha. We also have up here, sine of alpha. So you can figure out from the picture, or on this case, we have one given to us. Our opposite over hypotenuse, negative 5 over 13, is sine of alpha. How about cosine of pi over 3? One half. Pi over 3 is one of the ones on the unit circle. So we're going to need to be able to pull those up. Whether it's writing under the unit circle, pulling out your unit circle, it's going to be 1/2. And then we're going to keep going. We're going to have our subtraction. And we're going to do sine of pi over 3. So we just thought about that one. Square root of 3 over 2. And then this is the piece where we really needed that sketchy sketch to the side. Because we need cosine of alpha, which is what we weren't told. So cosine of that angle, negative 12 over 13. Order of operations means we're going to do our multiplication and then do our subtraction. So we wind up with negative 5 over 13 times 1/2. Multiplying across, negative 5 times 1 is negative 5. 13 times 2 is 26. And we're going to subtract square root of 3 times negative 12, which we really don't get to simplify. So it's going to be negative 12 square root of 3 over 26. And we're going to simplify this again, because I want this as one fraction. What are we going to wind up with? Not quite. Can I combine them together? Negative 5 and 12 square root of 3. We just need to be really careful though, because I've got a double negative situation going on here. So we have, you can either do it as negative 5 plus 12 square root of 3, or you can do 12 square root of 3 minus 5. I don't care. The book tends to write them out this way. So if you're looking at things like answers in the back of the book, it'll do it this way because they don't like to start it with a negative number unless they have to. But they mean the exact same dang thing. I don't really care. They mean the exact same thing. But so this is our final answer. We're going to keep practicing with things like this because these are weird. All right, same vibe. We're given conditions, and we're asked to find the exact value of this cosine expression. So we know secant of x is 3, cosecant of x is less than 0, and we're asked to evaluate the cosine. So this is our goal. That's our end piece that we're looking to work on. So sometimes right off the bat, it's hard to spot the quadrant until we remember that secant is the same as 1 over cosine. So we could switch this to be cosine of x equals 1/3. So we know our cosine's positive. And cosecant, that's 1 over sine of x. And that's less than 0. So we know sine is negative. So if cosine is positive and sine is negative, what quadrant are we going to be in? Four. Remember, my cosines are my x's and my sines are my y's. So my sine being negative means we're on the bottom half. And we know we've got an angle somewhere in quadrant 4. Here's this one. We know from the cosine of x, we know the adjacent and the hypotenuse. Adjacent is 1, hypotenuse is 3. So we're going back to remembering some of our old triangle formulas, our old triangle situations from way back in the trig days. So let's figure out our last leg. Let's figure out b. So we can use the Pythagorean theorem again to figure that out. So we know 1 squared plus b squared equals 3 squared. 1 plus b squared equals 9. So b squared equals 8. So what is b? Huh? I heard somebody say something. I can't hear about my heater. Two square root of 2. We can do square root of 8. Split that up into b square root of 4 times 2. 2 square root of 2. So we're going to find all of our pieces in order to evaluate the expression. Yes. It would indeed be a negative 2 square root of 2. I've got to fix that over here. Negative. I'm just going to erase the b and put it there. Because we know we're in quadrant 4. We know that that one's got to be negative. We know our sine is less than 0. That's this guy. So then we're going to come use our difference of cosine formula. Cosine keeps its cosines together, keeps its buddies together. So we're going to have cosine of x, cosine of pi over 4. It uses the opposite sign, so it's going to use a plus. Sine of x, sine of pi over 4. All of these pieces we could evaluate. So we want the cosine of our angle x. what's going to be the cosine of angle X? What's cosine of X? 1 over 3. What is the cosine of pi over 4? Square root of 2 over 2. Then we're going to do the sine of X. Negative 2 square root of 2 over 3. And sine of pi over 4? Square root of 2 over 2. So we're going to simplify each of these multiplications first. There we go. So 1 times square root of 2 is square root of 2 over 3 times 2, which is 6. And we're adding that to negative 2 square root of 2 times the square root of 2. What do we get as a numerator over here? Negative 4. The square root of 2 times square root of 2 becomes 2. So we have negative 2 times 2 over 6. Can I combine those together when we add them? No. So when we put this as a single fraction, we're going to have square root of 2 minus 4. Or you can do negative 4 plus the square root of 2. Genuinely, I do not care. It does not matter. They're mathematically, they done. I did the same thing. Okay, but these are just like weird and take some getting used to. So it feels like doing too much, because it is, but we can do it, because we're awesome like that. Okay. I'm going to leave this up here for a second, because I'm going to look through these real quick. Let's see. Okay. Okay. So we're going to do one more that's a little weirder, because they have one that's weirder, where they don't tell you either of the angles. They give you cosine of alpha and tangent of beta, and then you're asked to do 2 different trig functions of alpha and beta. So, like, it's a lot. And what we're going to do is we're going to make a sketch of alpha and what we know, and a sketch of beta and what we know, and we're going to use each of those. And since they don't tell us a quadrant, we're going to go ahead and just like assume it's quadrant 1, because all those values are positive. So for my alpha, which I will do in purple, we know cosine is 4 over 5. So cosine, that's our adjacent over our hypotenuse, right? So I know that this side is 4. My hypotenuse is 5. What's this side going to be? You're on the right track, but think of it the other way. It's a special triangle. You can always use Pythagorean theorem if we need to. It's 3. It's a 3, 4, 5 right triangle. So this side's going to be 3. You can also come in here and go b squared plus 4 squared equals 5 squared. You're going to wind up with that being 3. Okay? Similar for our beta. I'm going to do it in this bluish. Again, they're not telling us about a quadrant. All these values are positive, so let's go with 1. So here's our beta. This time it's tangent. Opposite over adjacent. So we know down here is 15. Over here is 8. And this is not one we're going to know off the top of our head, so we can Pythagorean theorem it. 8 squared plus 15 squared. Gives us 64 plus 225, I think. Work our way down. Let's see what C equals. What's C going to equal? $17. We have calculators. We can use them. Use them. Use them. So by getting these written down, we can then come and use these sine and cosine formulas. We could use the tangent formula. We could use whatever ones we need to figure out the addition of these two angles, even though we don't know much about those two angles individually. So we'll probably only have time to actually do one of them, but it gets us the vibe for when we're doing the homework. So sine does a little bit of each. So we're going to have sine of alpha, cosine of beta. Sine keeps the signs the same. Cosine of alpha, sine of beta. So it takes one of each. The formula writes them the other way. Sorry, my brain likes to do AB, and I have a really hard time switching it for that formula. It doesn't matter because it's a product, so it doesn't matter which order we multiply them in. My brain like refuses to remember them. Sine, cosine, sine, cosine. I'm trying. So we can find each of these values. Sine of alpha. Opposite over hypotenuse. So we're going to have 3/5. Cosine of beta. Adjacent over hypotenuse. 15 over 17. Cosine of alpha. That one's even that they gave us. 4/5. It was in the definition. Sine of beta. Which is 8 over 17. Okay? So it feels like they've given us a lot more work on it. It's just that we have to draw 2 triangles. Okay? So it's just worded really, really weird, and I wanted to make sure we talked through that really, really weird wording. We are about 1.5 minutes from the bell. So you guys can multiply fractions. Like, that's a thing we are pros at. But this gave us that opportunity to kind of see this weird wording and not have to swim uphill both ways, try to figure this guy out. Okay? So that is the entirety of 7-2. We got to the end. Or 7-3, excuse me. Huh? Pre-com. To be fair, trig makes your brain hurt, and that is incredibly common. Yes, dear. Yes. How many sugar spiral? Spiral. Color preference. Okay. The top spiral is purple. What's that?
Did I get the problem right?
If you got extra credit. I was gonna say, let me check for cookie delivery today. Do we have anybody who can get the cookie that needs it? Tommy, you want your cookie?
Oh, sure, yeah.
He said I got it.
You already got yours. Trinity and Karis, do you guys want your cookies? Tommy.
Thank
I'm just doing this so I don't touch everybody's cookie. Uh-huh. Alright. That's all the cookies. That's... You got a cookie. You got a cookie. You got a cookie. Oh, Monica got hers too, but she didn't. Oh well. Alright.